Hello students, welcome to chemistry class. It is the second session of solid state chapter. In previous video we have discussed about the introduction part of the solid state chapter and classification of solids, along with that classification of crystalline solids. And in this session we are going to discuss about crystal lattices, unit cells, parameters of unit cell, classification of unit cell, and 7 types of crystal systems, as well as number of atoms in a unit cell. So these are the concepts we are going to discuss now. Okay student, before that just see this box. In this box, or you can call it as a cube, how many number of faces are there here? How many number of faces are there? See, this is one face, 2 face, 3 face, 4, 5, and below one 6. 6 faces are there. Then these faces are joined by this point, this line of point. So this is called as edge. This is another edge. This is edge. 2 faces are joined by this. This is called as edge. So how many edges are there here? 1, 2, 3, 4. Above 4, and what about below? 1, 2, 3, 4. So 4 plus 4, 8. Plus side C, side edges 1, 2, 3, 4. Side also 4 edges are there. Total 12 edges are there. Okay. Then how many corners are there here? See here, 1 corner, 2, 3, 4. Above 4. What about below? Here also 1, 2, 3, 4. Below 4. Total 8 corners are there. Total 8 corners are there. Okay. Let us keep it aside. Now let's understand this concept. What do you mean by crystal lattice or space lattice? This crystal lattice is also called as space lattice. See here, this is called as crystal lattice. See, this is also looking like this crystal lattice. Okay. See here, crystal lattice means a regular 3-dimensional arrangement of lattice points in a space is called a crystal lattice or a space lattice. See here, regular 3-dimensional arrangement of these lattice points in a space is called as crystal lattice. Then another question arises here. What do you mean by lattice points or lattice sites? See here, these points are called as lattice sites. So what do you mean by lattice sites then? Each points are occupied by constituent particles. Those particles may be ion or atoms or molecules. Those ions or atoms or molecule occupied by these points, these all points, those are called as lattice site or lattice points. Okay, once again I will repeat. Lattice point or lattice site means it is a point occupied by constituent particles is called as lattice site or lattice point. And once again I will repeat, this space lattice or crystal lattice. It is a regular 3-dimensional arrangement of lattice points in a space, that is called as crystal lattice. Okay. Next, unit cell. See here, this is a shaded part. See here, just see the shaded part. This is a shaded part. The smallest repeating portion of this crystal lattice The smallest repeating unit of this crystal lattice is called as space lattice, or the smallest repeating portion of this crystal lattice is called as unit cell. This shaded portion is called as unit cell. See, once again I'll repeat. The smallest repeating portion of crystal lattice which generates the entire crystal when repeated in different directions is called unit cell. So this is called as unit cell. Okay, I think you understood unit cell, lattice point, and space lattice or crystal lattice. Next, move on to the parameters of unit cell. Parameters. Then what are those parameters? See here, I said you already, the smallest portion of crystal lattice is called as unit cell. The unit cell has a 6 parameters. Unit cell has a 6 parameters. One, see here, this edge length and this edge length, this edge length. So this is called as A, this is B, this is C. And the angle between B and C is called as alpha. The angle between A and B is called as gamma. The angle between A and C is called as beta. So these 3 edge lengths and 3 angles are considered as a parameters of unit cell. See here, a unit cell contains 3 edges A, B, C and angles between the edges alpha, beta, gamma. So these are called as parameters of the unit cell. Okay. Now let us study about the classification of unit cell. Next, classification of unit cell. See here, classification of unit cell. The unit cell can be classified into 2 types: primitive unit cell and centered unit cell. Primitive unit cell and centered unit cell. Then what do you mean by primitive unit cell or simple cubic unit cell? Primitive unit cell, or else it is called as simple cubic unit cell. Then what do you mean by simple cubic unit cell? See here, the constituent particles present only at the corners. See here, these are the corner. It is a corner, it is a corner, it is corner, it is corner. These all are corners. So the constituent particles means it may be atoms or ions or molecules which are present only at the corners. Those are called as, this type of unit cell is called as primitive unit cell or simple cubic unit cell. Once again I'll repeat, the constituent particles present only at the corners, that is called as primitive unit cell or simple cubic unit cell. See here, once again I'll repeat, in this type of unit cells, the constituent particles present are present only at the corners of the unit cell. So it has 8 corners or 8 lattice points. So these are called as lattice points. Already I said you, what do you mean by lattice point? Each point, these points are occupied by the constituent particle. Those are called as lattice points. So 8 points are there. So 8 lattice points are present in the primitive unit cell. Next, another classification here, centered unit cell. Then what do you mean by centered unit cell? See here, the one or more constituent particles present addition to these corner particles. One or more constituent particle present addition to the corner particles. Those type of unit cell are called as centered unit cell. See here, the unit cell which contains one or more constituent particle in addition to the corner particles is called as centered unit cell. Okay. Again, centered unit cells are of 3 types. First one, body centered unit cell. Second one, face centered unit cell. Third one, end centered unit cell. Then what do you mean by body centered unit cell? See here, body centered unit cell means in this type of centered unit cell, In addition to the particles at the corners, there is one particle at the body center. In addition to the corner particles, there is one particle present at the center of the body, that is called as body centered unit cell. Then what about face centered unit cell? See here, in this type of centered unit cells, in addition to the particles at the corners, there is one at the center of each faces. See here, there is one particle at the center of each faces. So 6 faces are there, 6 particles present at the center of each faces along with the corner particles. That is called as face centered unit cell. Once again I will repeat, this type of centered unit cells, in addition to the particles at the corners, there is one at the center of each faces. Those are called as face centered unit cell. Next one is end centered unit cell. In this type of centered unit cell, in addition to the particles at the corners, there is one at the center of any 2 faces. See here, once again I will repeat. In addition to the corner particles, if the particle present at the center of 2 opposite faces, such type of unit cell is called as end centered unit cell. See here, the particles present either these 2 faces or these 2 faces. Such type of unit cells are called as end centered unit cell. Once again I will repeat, this type of centered unit cell, in addition to the corner particles, there is one at the center of any 2 opposite faces, that is end centered unit cell. Okay. Next we are going to study about the classification of one second. Next we are going to study about the 7 type of crystal lattice. See here, 7 type of crystal lattice. Okay, 7 type of crystal systems based on the values of A, B and C and alpha, beta, gamma. There are 7 types of unit cells or crystal systems. They are, see here, cubic, tetragonal, orthorhombic, hexagonal, rhombohedral, monoclinic and triclinic. These 7 are the crystal system. See here, crystal system, possible variations are Bravais lattices, axial length, axial angle. Example, see here, just now I said based on the values of A, B, C and alpha, beta, gamma, there are 7 types of crystal systems. See, based on the value, already I said you, A, B, C and alpha, beta, gamma are the parameters. Based on these parameters we can again discovered 7 crystal systems: cubic, tetragonal, orthorhombic, hexagonal, rhombohedral, monoclinic and triclinic. So if A equal to B equal to C, alpha equal to beta equal to gamma equal to 90 degree, then that is a cubic crystal system. If A equal to B is not equal to C, alpha equal to beta equal to gamma equal to 90 degree, then that is a tetragonal crystal system. If A is not equal to B is not equal to C, alpha equal to beta equal to gamma equal to 90 degree, then that is said to be orthorhombic. See, you can remember example matchbox. It's an example for this matchbox. See, in matchbox, edge lengths are not equal, but angle is 90 degree. A is not equal to B is not equal to C, alpha equal to beta equal to gamma equal to 90 degree. You can remember matchbox for this. Next, hexagonal. A is equal to B is not equal to C, alpha equal to beta equal to 90 degree, gamma is equal to 120 degree, then that is said to be hexagonal. If A equal to B equal to C, alpha equal to beta equal to gamma is not equal to 90 degree, then that is a rhombohedral. If A is not equal to B is not equal to C, alpha equal to gamma equal to 90 degree, beta is doesn't equal to 90 degree, then that is a monoclinic. If A is not equal to B is not equal to C, alpha is not equal to beta is not equal to gamma is not equal to 90 degree, then that is said to be triclinic. If these parameters are there, then that is a triclinic crystal system. Okay. These are the axial length and axial angle. Based on this, we have classified the crystal systems, that is 7 crystal systems. So in this 7 crystal system, there are Bravais lattices. So Bravais has discovered these lattices, hence these are called as Bravais lattices, or else these are called as possible variations. In cubic crystal system, there are 3 Bravais lattices: primitive, body centered and face centered. In a tetragonal, there are 2 Bravais lattices: primitive and body centered. In orthorhombic crystal system, there are 4 Bravais lattices: primitive, body centered and face centered and end centered. In hexagonal, there is a 1 Bravais lattice, that is primitive or simple cubic unit cell. In rhombohedral or trigonal, there is also only 1 Bravais lattices, that is primitive or simple cubic unit cell. In monoclinic, there are 2 Bravais lattices: primitive and end centered. In triclinic, there is 1 Bravais lattice, that is primitive, only primitive or simple cubic unit cell. So the example for each Bravais lattices are, for cubic Bravais lattices, for cubic crystal system, the examples are zinc blende, sodium chloride, copper, diamond. These are the examples of cubic crystal system. White tin, tin oxide, titanium oxide, calcium sulfate. These are the examples of tetragonal crystal system. Rhombic sulfur, potassium nitrate, barium sulfate. These are the examples of orthorhombic crystal systems. Okay. Similarly, graphite and zinc oxide, cadmium sulfide, ice and silver iodide. These are the examples of hexagonal crystal system. Calcite, cinnabar, sodium nitrate. These are the examples of rhombohedral or trigonal crystal system. Monoclinic sulfur or hydrated sodium sulfate. These are the examples of monoclinic crystal system. Potassium dichromate, pentahydrated copper sulfate and H3BO3. These are the examples of triclinic crystal system. Okay, these are the very important 7 types of crystal system, and along with the Bravais lattices. Just count here how many Bravais lattices present in the 7 crystal system. 3 plus 2 total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 Bravais lattices are present. 7 crystal systems are there. 14 Bravais lattices are there. They may ask in exam, see here, how many Bravais lattices present in a cubic unit cell? Or else how many Bravais lattices present in a tetragonal unit crystal system? How many Bravais lattices present in a orthorhombic crystal system? How many are there? 4 Bravais lattices present in a orthorhombic, 2 Bravais lattices present in a tetragonal, 3 Bravais lattices present in a cubic unit cell. So 1 hexagonal, 1 are rhombohedral or trigonal, and primitive and center 2 in a monoclinic. In triclinic, only 1 Bravais lattice is present. You should remember this table. It is very important table. It is also important for the competitive exams. See here, in triclinic it is a irregular shape. Triclinic crystal system is in a irregular shape. You can remember by remembering the irregular shape. Okay, this is about the crystal systems. In competitive exam, they may ask like this: A equal to B is not equal to C, alpha equal to beta equal to gamma equal to 90 degree. Then which type of crystal system it is? Based on this value, we have to say it is a tetragonal crystal system. Okay, see once again, see this table. Okay. Now let us study about number of atoms in a unit cell. Number of atoms in a unit cell. Okay. Before understanding number of atoms in a unit cells, first you should understand that. See this table. Position of the atom, number of unit cell with which shared contribution towards one unit cell. See here, first you should understand this. See here, these all are lattice points and these are corner atoms. For this unit cell, it is a crystal system. The smallest portion of the crystal lattice is called as unit cell. In this unit cell, 1, 2, 3, 4, 5, 6, 7, 8. 8 corner atoms are there. Okay. These corner particles here, I will consider this corner particle. See, above 1, 2, 3, 4 unit cells are there. Above, below also 4 unit cells are there. This atom, this constituent particle shared by 8 unit cell. So the contribution of this corner particle to one unit cell is 1 by 8. Okay, because this is shared by 8 unit cell, the contribution of this corner particle to one unit cell is 1 by 8. Okay, see here. Here see, position of atom, corner particle, corner atom, edge center atom, phase center, body center. Number of unit cell with which shared. Corner atom is shared by 8 unit cell. Just now I said you, corner atom is shared by 8 unit cell. Hence the contribution towards one unit cell is 1 by 8. And edge center. The edge center is shared with 4 unit cells. See here. This is the edge. See here, this is one unit cell, this is another unit cell, this is another unit cell, this is another. Total 4 unit cells are there. Here one constituent particle is present at the center of this edge. This edge center particle, this constituent particle shared by 4 another units, 4 unit cells. Hence the contribution of this constituent particles to one unit cell is 1 by 4. So edge center unit cell shared by 4 unit cells. So contribution towards the one unit cell is 1 by 4. Phase center unit cell. See here, this is a